So the first thing I'm going to do is just define what an extreme value really is. So it's the maximum or minimum value over a specific interval. So the next thing I'm just going to tell you guys about is just how to find the maximum value over an interval. So there's three different ways to do it. So the first is you solve for when the derivative of the function is equal to 0. So from previous lessons, you would understand that that would be for when there's a horizontal tangent. So an example would be, here this is a hill and then a valley, or what you would call it on the graph. And then the second thing that you need to do is find if the derivative is undefined anywhere over the interval. So an example would be, a cusp like this. It would show like this on the graph. And then the third thing that you need to do to find where there's a maximum value over the interval is actually test the boundaries of the interval. So in an example, it would tell you, the intervals for which the function you would need to find the maximum in. So you need to test those two boundaries as well. So and further, I'm just going to talk to you guys about what critical values actually are, because they're used interchangeably with the maximum values. So a critical value of a function is a number. In this case, we're using c, in the domain of the function for which either the derivative of the function when you input that critical value is equal to 0. So again, it's just talking about the where the tangent is horizontal or equal to 0, or where the derivative of the function with in terms of c is undefined. So where in this function is undefined would be the number c. So now that we have some of our definitions down packed and some background information about exactly what an extreme value is, we're going to go into some depth about what the actual finding the absolute extrema algorithm is, or essentially just what the steps are in finding these. So the first thing that we just need to denote is that y equals f of x needs to be a continuous function over the interval ab. And then so the first thing that we're going to do is find all of the critical values of f over ab. So I did mention that earlier, is just, we get our function, we find the derivative, and then we set it equal to 0. So say if the function is in terms of x, we would find where all of the places where x is equal to 0, which essentially what I said before is where it is equal to 0, and that is our critical value. And then the second step is to evaluate f at a and b, so our two intervals, and at each c found in step 1. And we also need to make sure that we take into account that where, the critical values aren't just where the derivative of the function is equal to 0, but also where the derivative is undefined. So we'll go into that more depth about that in one of our examples as well, just so you can actually see, it's not just where the function and the derivative of the function is equal to 0, but also where it's undefined. And then so the third step is once we found all of our critical values and we use the a and b, which is our interval, we plug those in to our original function, and then the largest value that we obtain from doing that is our absolute maximum over the interval AB, and the smallest value is the absolute minimum over AB. So our first example is to determine the extremas over the interval of -5 and 1 with our function g of x is equal to x to the 2/3 times 5 plus x. So I've already gone ahead and done most of this example, so I'm just going to be doing it verbally with you guys. So the first thing that we're going to want to do is find the derivative of g of x to find the critical values, as mentioned in our absolute extrema algorithm. So to find the derivative of g of x, we note that this is a product rule, so it's one function multiplied by another function. So the first thing that we're going to do is find the derivative of the first and multiply it by the second, plus the first and times the derivative of the second. So it's going to be 2/3 x to the exponent a -1/3, which is obviously just the chain rule, multiplied by the second function plus the first function times the second function, the derivative of the second function, which is just 1. And then next, I'm just going to, simplify the derivative a little bit further. So it's just going to be 2 over 3x to the 1/3 because we don't want negative exponents. And then times 5 plus x plus x to the 2/3, because times 1 is just x to the 2/3. And then what we're going to do next is set the function equal to 0. So you've noted this from the other lessons that when we're trying to find horizontal tangents, we need to set the function equal to 0 because that's where, the slope is going to be equal to 0. So again, I'm just simplifying the function a little bit further. So it'll have 2 times 5 plus x 3x to the 1/3 times x to the 2/3, and then over 3x to the 1/3. So if you're a little confused about what I did right there, I just set this all over to the same denominator because we're going to need to do that to solve the extreme value. And then so I just multiplied the second function by the denominator of 3x to the 1/3. And then after we find that, it's just another simplification. So it's going to be, it's going to be 0 equals. So what I did, I kind of did 2 steps here. So I did, I moved the denominator, I divided both sides by 3x to the 1/3, or I multiplied both sides so I can get rid of the denominator. And then so it's going to be 0 equals 10. So I just did 2 times 5 plus 2 times x. And then this 3x to the 1/3 times 2 over to the, or x to the 2/3 is just going to be 3x. And then you can kind of see it there. I'm sorry about that. But then simplify it even further. 0 equals 10 plus 5x. And then x equals negative 10 over 5, which is just x equals 2. So we found all of this critical value where it's equal to 0. But we can't forget about where the function is undefined. So now I'm just going to be doing this with you guys right now. So we're just going to write our original equation of x to the 2/3 times 5 plus x. And then again, it's just going to be over the interval 5, 1. And then so we need to find where the derivative of g of x is undefined. Now, it's obviously apparent that not all functions will have the derivative where it will be undefined, but this is a case where it will be undefined. So g prime of x is equal to 10 plus 5x over 3x to the 1/3. And then so we're going to try and find where this would be undefined. So obviously with the denominator, it can't equal 0 because a number divided by 0 is a math error. It can't be found. So we're going to set the denominator, which is 3x to the 1/3 equal to 0, where it's going to be 2b undefined. So basically through simple math and everything, it's going to be where x equals to 0 because 3 times 0 to the 1/3 is still just going to be 0. And then 10, no matter what that x is going to be, so 10 divided by 0 would still be undefined. So that's where we found our 2 other critical values. So it's going to be, x minus 2 and 0. So then now we're just going to evaluate, which is our third step, to find the absolute max and min. So I'm just going to do this in order of the numbers, how they appear. So the first one is g of the interval to the left, so negative 5. And then we're going to do g of negative 2, which is the critical value that I found at the beginning. G of 0, which is where I found it to be undefined. And then g of 1, which is the second boundary of our interval. So I'm just going to do this quickly with you guys. You just punch in negative 5, obviously, into the function, the original function. 2 over 3 times 5 plus negative 5. So you guys, it's pretty simple here. It's just going to be, 5 plus negative 5, sorry, bracket there. It's just going to be 0. Anything times 0 is 0. And then so negative 2, we do the exact same thing. 2 over 3 times 5 plus negative 2. And then here we get kind of a funky number. And then obviously if we're trying to find an absolute max or min value, I off the top of my head do not know that number. So I'm just gonna it's okay to simplify it into a decimal fraction just so we can get in terms. It doesn't have to be exactly exact, but we just need to know, where the max or min right now. So right now I can already tell the max would not be -5 because this -2 already has a higher value than that. So I'm just going to keep this into my head, that might be the absolute max. And that could be the absolute min because, max or min. And then also we're going to do g of 0. So 0 to the 2/3, 5 plus 0. Again, 0 to the 2/3 is going to be 0. Multiplied by anything will just be 0. And then g of 1 is going to be 1 to the 2/3, plus 5, or times 5 plus 1, which is going to be 6. So now that we can, that we've solved all of our extreme values and, the boundaries, we can kind of get an understanding of where the absolute max and min values are. So 6, by looking at this, I can tell that 6 is our highest number. And then we also have our two lowest numbers, 0 and 0, which is totally fine. It's just we're going to have two absolute mins. And then this 4.8 is kind of in the middle of everything, so we just discard it. So with that, we're going to want to make a therefore statement. So our therefore statement is therefore first I'm just going to do the absolute maximum. The absolute maximum is 6 when x is equal to 0, or you can essentially just write it's going to be 1, 6. That's our absolute max. And then I'm also going to write a therefore statement for the minimum value because it asks for both. The extremas, you denote the maximum and the minimum because it's just, And then so the absolute minimum, is 0 when x is equal to -5 and x is equal to 0. And then again, we can just write where it's going to be -5 and 0. And then also at the origin 0, 0. So our second example will be to determine the absolute maximum or minimum values of the function f of x is equal to 3 times x minus 1 squared over 2x minus 7 plus 4. So again, I just want to make sure that you guys know that the absolute maximum and minimum is also the same thing as saying the extremas of the function. And also in this example, we're going to be using a harder function just to get you guys thinking a little bit more. And also the steps along the way might be a little bit, you need to think a little bit more than our other example. So it really gets you guys to see every aspect of finding the extreme values of the maximum and minimum. So in our first step that we found by, writing down the absolute extrema algorithm is to find the derivative of f of x. But first, I'm not going to do the derivative. I'm just going to simplify this expression a little bit further. So it's just going to be 3x squared minus 6x plus 3 over 2x minus 7 plus 4. You just want to simplify everything as much as you can, so when you're finding the derivative, you make sure that you're as error-free as possible. So now I'm actually going to find the derivative of the function. So this is a key example of the quotient rule. So the way that I, made a little song in my head is down, up prime, minus up, down prime, all over, down squared. We also need to recognize that this 4 will just cancel out because the derivative of a constant is just 0. And then we're just going to simplify this even further before, setting it equal to 0. So it's going to be 12x squared minus 12x minus 42x plus 42 minus 6x squared minus 12x plus 6 Sorry, that seems a lot, but it's basically just doing FOIL here, and then just putting this 2 into the equation, all over 2x minus 7 squared. And then I'm going to still simplify this even further. So this 12 cancels out because negative 12 plus 12 is just going to be 0. And then so we're left with 6x squared because 12x minus 6x is 6x, or squared, sorry. And then minus 42x plus 36 because 42 minus 6. And then this, it just stays the same. And then again, we can't forget about this 2x minus 7 squared. So now we can set the equation equal to 0 to find the extreme values. So first I'm just going to take out the 6 in the numerator, so x squared minus 7x plus 6 all over 2x minus 7 squared. So now I'm going to send this over, and then so it'll just, all we will be left with is just going to be 6x squared minus 7x plus 6. And then you guys should just know that from our previous lessons about where we're going to solve where x is equal to 0. And then now we can just do a simple factor of 6, and then we get x minus 1 and x minus 6. And then again, this is all equal to 0. So from that, I'm going to get x is equal to 1, and then x is equal to 6. So this is where it gets a little bit, not complicated, but just tricky. So we found the critical values of the derivative of the function, but we also need to make sure that it has to be in the interval because that's all that we're talking about. So if our interval, sorry if you just see it down here, is just -4 to 2. So 1 is definitely in that interval, but 6 is not. So what we would do is just dismiss this, and then we just need to keep this in mind as well. X is equal to 1. And then our second step is to find, again, where f prime of x is undefined. So I talked about this again in our first example, so I'm just going to go straight to it. If you see in our function right here, the f prime of x, we note that the only place where it would be undefined were to be if the denominator were to be equal to 0, because again, 0 divided by any number, or any number divided by 0, sorry, would be undefined. So all I'm going to deal with is setting the denominator, which is, sorry, 2x minus 7, and set it equal to 0 to find where x would be equal to 0, because that's where it would be undefined. And then so we get 2x equals 7, and then 7 is equal to 7, or x is equal to 7 over 2, which is approximately, or which is 3.5. And again, we can be using decimals in this case just because we're trying to find like a number on our graph. So now that we have some critical values over here, which is x equals 1 and x equals 3.5. So the thing is, we did find this, dismiss this, and then we found where the function is undefined. But 3.5 is not in our interval again, so we need to dismiss this once more. See, this is just where it gets a little bit tricky, and you need to think a little bit more, because it's not just where you find the critical values, because we're only testing for the interval, so these wouldn't even matter. So what I'm going to do next is I'm just going to, bring this all over up here. And then I'm going to do our third step, which is testing the intervals and also testing our extreme value. So I'm going to do the first boundary of the interval, f of -4, and just put these in order. F of 1 and f of 2, which is our last boundary. So I'm just going to save you guys a little bit of steps. You can do this on your own, and then maybe you can solve it a little bit more. So when you sub -4 into the equation, you get 1. When you sub in f of 1, you get 4. And f of 2, you get 3. So here I can see this would be our minimum value, and this would be our maximum value. And so now our last step is to write our therefore statement. So the absolute maximum is 4 when x is equal to 1, and then therefore the minimum, or the absolute minimum, is 1 when x is equal to -4, or we can simply write the minimum, just to clean it up a bit, is the point is -4 and 1, and then our maximum is equal to 1 and 4. So that's our lesson for finding the extreme, for finding the extreme value and algorithm. So I'm also just gonna give you guys some textbook questions that I found really helpful in furthering my learning for finding the for finding the extreme value algorithm and using it and everything. So it's just going to be on our regular textbook, which is page 135, and I'm just going to give you a lot of different types of questions in this. And obviously you don't have to do all of these. These are just kind of my recommendations that I found really helpful and really advanced my learning in this type of lesson. So I hope you guys enjoyed it, and I'll be also attaching the quiz, which will have some more functions that you need to find the absolute maximum minimum value, and also some communication questions as well. Thank you.